So last time we finished working on A* pathfinding, and it works with a few caveats. And today I want to expand it to actually do Theta*, so like collapse different nodes so that the character is actually moving in a straight line as long as he can. It seems pretty simple. The algorithm, all it's doing is for every neighbor it will like replace a parent with its own parent if that parent is in line of sight using this I think it's Bresenham line of sight algorithm. Yeah, so that should be not that difficult, hopefully. Or something else. If we look at where we call it for drawing, yeah, so we're going from this position to the float position that is the target. But in actual pathfinding, we are rounding those so that we get tile coordinates in integers, because it's discrete tiles, obviously, the map. And I realized two things. One is that I don't need to, if you look at how I reconstruct my path, I don't actually need to include the from oh, right, I go backwards. Yeah, I don't need to include from I here. The first node can just be a node, or the next node for you to step on. That's one. And also it's still going to work with floats here, because we can just presume that that's where we are and we get our first target that will be like in a straight line, and we'll just move to the target not from the center of the tile as we rounded, but from wherever we are. That's one. And two is we do need to actually move not to the integer of the target, not the integer position of the target, but the actual float one. So for that, I think we could just replace maybe this target, or I mean in the reconstructed path we could replace this guy. When we add that last node to the path, we could just use the actual float position. But now that I say those two things out loud, I feel like there is one problem potentially, and I don't think it matters, to be honest, but the way the path is going to be constructed could actually be different if we started from a float as opposed to that rounded to the integers. Right? What I mean by that is it would be the same unless we encountered any obstacle. But if there is some kind of obstacle that or let's say, I don't know, you're going pretty far and then you're walking around like some kind of column at a distance from you, so you get a bunch of points at like small angles from you. I don't know if it works exactly like that, but you have like a bunch of targets far away from you, so it forms like, like if you look at those targets from your position, you're moving only a small angle, rotating only a small angle, right? And you're going to potentially collapse some points in that path with theta star. But because you weren't counting from the float position, you would collapse to like the wrong point. Not the wrong point, but like you wouldn't be able to collapse as many points. Or I guess it could even be possible that you collapse in a way that makes you like phase a little bit through a wall or something. Okay, so that's one thing that consists of two things, I guess. The other thing is that if we look at this, there's a bit of a problem. Maybe don't move there. Maybe don't move there. Where the hell is this? It's kind of growing big a little bit. Yeah, don't do this. Just show it. What do we do? Or what did I do? Oh. Okay, so you can see, and actually it's enough here, you can see this path. Now it's hard to tell because of this font. It's very like, has a lot of empty space. Like you can see this is adjacent. So like there's that much empty space between actual glyphs. But if it was, you know, imagine an actual tile set drawn, that maybe this is a wall that takes the whole sprite or the whole tile. And maybe this guy is more kind of pronounced, right? Not just a symbol. Well, you will see that he's actually going to collide with his side like this, right? Yeah, so, I mean, it's kind of a problem in general, I guess number 3 that I'll mention. But in this case, it's simpler than that problem. In this case, I think, and I thought of multiple ways of doing this, but I think the easiest way would actually to just not process diagonals, right? And I realized two things. That actually, yes, it will make a less efficient path if we're just, let's just talk A star, right? It will make a less efficient path. Excuse me. It will pick a path with more nodes in it, but actually, in regards to open set, it will be more efficient, I think. Because right now, if we're checking our stuff, checking our nodes, when we get neighbors, right? We will be checking 8 neighbors. And we will be adding what are we doing with neighbors. Is potentially we're adding them to our open set. Right? And what do we do with open set? We pull nodes from it. We look for the least F-score node and take it, remove it, and consider its neighbors, right? So we can see that actually not processing diagonals would make the crux of the algorithm more efficient. Or I don't know if it would be more efficient, but it would be faster, right? And of course you would say, but the path is worse. And that's true. But we're going to be doing theta star. So actually it's not going to matter, because just like how we would collapse, I don't know, like for example, let's imagine this path. What would happen if we didn't cross diagonals? Well, we would walk this way, and that's fine. This is exactly what we want. And then he would walk from here to straight here. This would be the next target. And then since this is our target, the A star is going to be like this, or you know, maybe even as a staircase, right? But we will actually collapse those anyways. Like all of these, the parent of this node will just be this one, right? So that's my theory, is that this is actually just better. And think about this, it's even better for theta star itself, because smaller open set, less people we have to consider, less neighbors we have to check, right? And thus we have to do that expensive line tracing algorithm. Thus we call it less, right? So I think that would just be better. And then what was the problem number 3? So problem number 3 is that we're only considering the player as a point. And he's moving in float space, so he's actually going to be moving through targets. So what's going to happen is, if you imagine a path kind of going like this, and like it will collapse the node so that it's a straight line, but that straight line will like, it won't touch this node itself, but it will be like right on the verge of it. So when the whole player volume is moving, that player volume would like cross into it. Even though the center wouldn't, the player would still cross into it. And like, it's okay a little bit, but I think we want some control over that. We want some more substance to the player. So I think that we should have a little volume around the player. And I think that what that means is that when we do this line of sight thing, and we'll see, because it is going to be working in integers, I believe, and we're going to have to work in floats for that. But I guess this is the thing that matters, right? Like checking the actual collision. So I guess when we do that for each point, we'll just round it back, right, to integers and see if it's colliding or whatever. But how we actually trace our line would be, I think it would be pretty simple if we can get that to work in like float space. But the basic idea would be is that player has a radius, and then when we're doing that line of sight thing, we're not just going from the center of the player, which we assume that to be in the middle of a tile, and any target inside of the path will be in the middle of a tile. So yeah, so since we're tracing a line from target to target, we're tracing from middle of tile to middle of tile, right? So what that means is that that's like well defined. We can actually, I guess let me draw this. So we'll have something like this. This is one target, this is another target. And like they are on a grid right in the middle of tiles. So what we do is, instead of just tracing line like this, now check this out, it's going to be the best line in the world. I'm still so bad at drawing with tablet. Or I guess without tablet for that matter. Oh, I'm so far from mic, by the way. Yeah, instead of doing this, we have this line. We can take perpendicular, right? And like, this is our radius, and we cast it also to here. Does that even look like R? Okay. Right, so we basically cast two lines, and we check if any of them crosses. Now that I draw it out, I wonder if it matters, the volume, this volume itself, whether it matters. No, because I mean it's on the grid, everything's on the grid. So if it's going to collide, it's going to collide with one of these lines. I guess assuming the radius is smaller than one tile. Tile W over 2. What else? Yeah, so then instead of tracing this one line, this guy, we trace, I guess I don't erase, or actually, maybe I do, but, oh, what the fuck? I don't know what's happening. Something's broken. Oh, really? Okay. I don't know what that was. Okay. Let's just do this. Oh, it looks like a road. Alright, anyways. So, it's pretty simple, right? Instead of tracing the one line, we're tracing two lines. And it's going to be from a float position to float position. But each of these points, or I guess, yeah, like, I don't know. I don't know exactly how that's going to work. Wait, I think this isn't floats. Okay, anyways, I think it's possible, but I don't know if it would be a good idea, to be honest, because of it just makes everything more expensive. But then of course we could try to optimize it, do some SIMD or something. But yeah, let's just not worry about this for now. That's a problem for later. So, okay. Let's just start with these problems. So for one, for the first one, I think it should be simple. I need to do just two things. One is I don't do this. So what do I need? I need like -1, 0, 1, 0, -1, and 1, 0. -1, hold on. 0, -0, -1, and 0, 1. Those are the only possibilities, right? So here we do this. We'll already take the node. Oops, we will need this basically in one way or another. And then here that's node. We will not have that anymore. That will just be 10. Oh yeah, we also want that to be passed by pointer. And then we will add that to here, and then I can just call a neighbor a bunch of times, result by pointer, level pointer, well, I can't do today, and this, right, we have node -1 and node +0. And then this will be node +1 +0. This will be +0 -1. This is going to be +0 +1. Maybe let's pass the cost in here. Right, 10, 10. Okay. So if I look at this, come on. Right, so again, I guess I can also simplify the cost function, the heuristic function, can't I? Like, there's no point doing this anymore. It is going to be, I think that's called Manhattan distance. I think it doesn't matter. Because even with that cost, that would still be the best. I mean, we don't have the diagonal, which would be better. So I don't know, maybe let me just do this. And then in this case, I think let's just do dist x plus dist y. Or you know what, let's just not do it for now. Because I don't know, I saw the function used in here. Like we get the, I guess we never get the heuristic. Wait, what? No, we do. Is it C? No, C is... C is just... Yeah. Okay, heuristic of neighbor. Yeah, it's fine. Let's just do this, just in case. Dist x plus dist y. I think that's sort of better now, even, because I guess it does less of that staircase stuff. So even that looks pretty good. But of course, we're gonna do better. I want to check something else. What do I want to check? I wanted to also check the size of my open set and like compare that and confirm my theory that it's gonna be better, but honestly, I just don't care. I don't care to check it. I think it's correct. I think it's pretty self-evident, and it would be good to compare the whole costs when we get to it, like the whole profile or time, the whole execution. But we can worry about it later. Okay, so let's extend this. What am I doing? All right. I got some coffee. Which is very relevant to this. Yeah, so it has this close-up, but I don't think I need it. I think I can keep everything the same. The only difference is that here, like instead of doing this, we do this update vertex function, which if there is line of sight between parent S and neighbor, then ignore S and use the path from parent S to neighbor. Otherwise, if the path from the start to S and from S to neighbor is shorter than the shortest currently known distance from start to neighbor, then update node with a new distance. If there is line of sight between parent S and neighbor, then ignore S and use the path from from parent to neighbor. Okay. What I don't get is how does it collapse more than one level? I guess because the next node that from this node we will go to will do the same, and it will do line of sight to the parent of S. Okay, so S is the current, right? No. Also, okay, we're going from my parent to my neighbors or my potential children. Okay. Okay. Okay, so I'll set the parent of my neighbor not to be me, but to be my parent. Okay. And then that guy will do the same with its neighbors, which will go basically to my parent. Okay. I think that makes sense. Then we got this line of sight. Mm. Cost from parent to neighbor. Cost. Um. Yeah, that's okay. It's just gonna be the cost from my parent to me, which would be in this case always 10. No, 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 if I skip parents. Oh. Okay, so I'm basically I decided to separate that apart into this one function, which is kind of ugly, but it's okay. So we have int node I here, vec2id x, level w and node. We have parent I, vec2id x, level w and parent. So we save that parent, we save this to be gscore, and this will be gscore, and it's going to call get hcost between node and, oh, we also need the 2. Hold on. Not the node. This is okay, yeah, now it's the node. But did I have it like that before? No, it was correct. Okay, and then we add the node to open set. Like that. But okay, I see. So there's more of a complication. Ugh. I wonder if I should just undo this. Yeah, this function is just, it just doesn't make sense. The list of parameters will be longer than the actual implementation. Okay, so let's just do this simply. You know what, let's just make the same functions they have. Update, let's call it node. Right, and we have the node itself, and we have the neighbor that we're coming from, or the node that we're coming from, and the neighbor. So we don't need to initialize, that's one thing. And then instead of all of this, we don't need to check the score either. If not an open, we initialize. Okay, I don't need that. So I just need to call this for each neighbor. If it's not enclosed, I also don't care about that. I guess this is more, it makes more sense in here because we're going to be actually tracing the line and not, like before it was just this check that we would be avoiding by having a closed set. But now it's a whole line tracing. Oh, you know, maybe it's not just that. Maybe, I think there will be a logical problem as well. Because like if we like, let's say this is the previous target, then we reach this guy, and this is the parent of this guy. We're checking its neighbors, and first of all, like we already checked this guy, right? We already went through this and we like collapsed him so that the I was gonna say straight line. We collapse it so that this is a straight line instead of like that, right? So we already saw that guy, but now we're saying like that, like it would make sense to collapse this guy into this guy because there's line of sight. I guess one thing is line of sight between parent and neighbor, right? So like that would be between this guy parent and this guy neighbor, which is, this is me. And I see the G-score if that G-score is less than the current G-score of the neighbor. I guess it wouldn't be less, right? Because it's the G-score of the parent plus the G-score of going, or just the cost of going from parent to neighbor, which is going to be less. And then no, I think it will be equal because the G-score of the neighbor will be parent plus, yeah, no, it would be the same, it would be equal. So I think logically there's no problem. But still, I think that's because like this guy would still be the same guy. He'll still have the same G-score. Like nothing changed here. We're still gonna be from, what the fuck? From here to here. It's all the same. Like this guy's G-score is the same, right? And then we have cost from this guy to this guy. It doesn't matter if we get it directly here when it's like, let's say it's this guy's neighbor, right? When we were considering this guy adding to open set, we're looking at this guy, let's say. Then we set his G-score, or I guess even when we considered the node itself from the open set. Yeah, and I only do this if it's less than. How annoying would it be to have a closed set? What is open set? Data count. I guess it wouldn't be that bad. I think let's do it. I don't know, to be honest, I kind of feel not on top of my shit this morning, let's say. So I could say that this is nav set, this is add to set. Set empty. Remove from set. is in set. And that's it. And then here, this will be not set, but it's still called open set. That's okay, that's okay. It might get big though. Like we never remove stuff from the closed set. So it might be way bigger than open set. Okay, maybe I'll remove it later. I'll just proceed with this. Add to set, open set, is set empty, open set. Yeah, this is still the same. Remove from set. And then is in set. Oops, and add to set. And then when I did reconstruct, is there set? No. Not open set. Anyway. No. Okay. Let me just open set. Besides these names. No. Okay. I think let's just initialize the closed set the same way. Then what do? We pop the open set, and right away we added so that is me popping. That's checking the goal. Doing that, then it pops. So I do it here, add to set, closed, set, node. And then we only check for it here. So we're doing it like this. So we get our thing, we get our neighbor, then we do if is in set, closed set, neighbor, not in set. Then we do something, and then if is not in set, open set, neighbor. Okay, I don't actually need to do that at all. Oh, we'll check again. Which is what this corresponds to. So I don't need to check it here. I just need to check if it's not enclosed set. Then I call update node. Update node. And then let's just move all this here. I guess the way, like, closed set does not need to be a set actually. It doesn't make sense for it to be a set, because that's just supposed to be like a flag whether we've visited this already or not. I see. Yeah, that's true. I wonder if I should change that now. I guess I can still call it nav set, whatever. But instead of having the closed set, I do B32 array visited. And this guy we need to 0. And it will be the size of the level. And the good thing about this is that it's bounded. And it's like in reverse. So first of all, the space is bounded, and second of all, I guess even then it's bounded, because we wouldn't have the same node in the set. But we're still only storing one 4-byte one 4-byte boolean as opposed to a whole position. And also we save on iterating, so that's constant time lookup. So I think it's good. So then when I get the node, I don't add it to close set, I just say visited at node I is true. And then here I check that visited is not true for neighbor I. Vec to I dx level w neighbor. Then we update the node. And that's the only time we're interacting with closed set. And then I can get rid of this. And then in here, if line of sight between so we can have int node I vec to I dx level w node, which means we need level pointer. And then if line of sight between parent of node I and the neighbor then something, otherwise something else. So we need parents, and then we need idx2 xy, which honestly I really need to start treating everything as just indices. Okay, so we also need parents, and then what we need here is I guess we can have this tentative. Let's actually put all of this in here. So that's the old way. Also, I guess I can do get Manhattan distance, get Manhattan dist, let's just do this. Right, so here we can just do 10, but here, oops, we'll do get Manhattan dist between node, between, I guess we're gonna have v to I parent is this. Line side between parent and neighbor. And then this will be Manhattan distance between parent and neighbor. Okay. And then this we do the same way. Because we also need this the same way. I guess we can do that here. Yeah, so we just changed the formula for tentative G-score here. But other than that, we do the same thing. We update G-score to that, which is equal to tentative, or to that, which is equal to tentative. We set the parent of the neighbor as either me or my parent. And if that neighbor, this is an important part as well. If that neighbor already was an open set, we remove it. And read so. Oh, it's not an important part. It's because this algorithm stores the cost in open set. The F scores. I don't. So that's done here. So then all I need to do is only add if it's not already in set. So I think we're gonna have parent to set here, and then here parent to set will be equal to parent, and here parent to set will be equal to node, and then we can move this whole thing here. And we don't need that then. So we check the tentative G-score, compare it to the actual G-score. We set the parent to set in that case. Then we set the G-score to be the tentative G-score. We set the F-score to be tentative discourse, I wanted to say. Tentative G-score. Oh, okay, so that's just getting this, which is this. Yeah. So it's still tentative G-score plus the heuristic, which is just Manhattan distance from neighbor to the endpoint. So we need the endpoint. It's really stupid that I call it 2 in here. Makes no sense. Let's call it end. What else do I need? I need G-scores, I need F-scores, I32 G-scores, I32 F-scores. I do have level, I do have parents. Open set. Nav set, pointer, open set. And I don't need to get the address of that. So I think it's something like that. And then we just update node with all of these parameters. Which is the node is the neighbor is the neighbor, end is 2, level is level, parents is parents, g-scores is g-scores, f-scores is f-scores, and open set is open set. Pointer. Alright, and we can also have a line of sight, internal font B32, line of sight for, we need the level, of course, and then B2I from, B2I to, and let's just return true. And here we can pass the level pointer as well. See if it builds. Nope. That's void. Oh, what the fuck have I done? The x to xy needs level W. Tentative score should be here. Parent to set should be back to IDX. I really hate these. I really should have treated them as indices. Okay, and I kind of just want to see what's going to happen with that line of sight function. I imagine it should just collapse the path always. It should just be straight line. Oh my god, come on. What the fuck? Okay, no, it's not working. And it's actually frozen. Are we stuck in here? Parents of 0 is 0. Okay. And who the hell is 0? What's 2i? From my 2i. 2i. What gives us 0? What the hell is Visual Studio? What gives us 0? I don't remember, was that wrong? Was the way the parents look here wrong? I don't think so. Okay, let's just do one. Check. 2, 3, 8, 2. Yeah, so that kind of looks wrong. I don't know. Okay. I think I have to debug this more in depth. But I gotta go now. So, see you later.